Firefly Aerospace's Blue Ghost Mission 1, a historic lunar landing. Firefly Aerospace is poised to make history with its upcoming Blue Ghost Mission 1 set to land on the Moon's Mare Crisium on March 2, 2025. This mission, funded by NASA's Commercial Lunar Payload Services CLPS program with a budget of $101.5 million, represents a significant milestone not just for Firefly but for private space exploration as a whole. Mission Overview. Blue Ghost Mission 1, also known as Ghost Riders in the Sky, aims to deliver 10 scientific payloads to the lunar surface supporting NASA's Artemis program, which seeks to return humans to the Moon and establish a sustainable presence there. The mission will enhance scientific understanding of the Moon and validate crucial technologies needed for future exploration. Timeline of events. Launch date: January 15, 2025, aboard a Falcon 9 rocket. Transit duration: approximately 45 days to reach the Moon. Landing date: March 2, 2025. At approximately 2:34 a.m. Central Standard Time. Surface operations duration: about 14 Earth days, corresponding to a full lunar day. Scientific goals and payloads. Upon touchdown near the volcanic feature Mons La Trail in Mare Crisium, the Blue Ghost lander will commence its mission, which includes a range of scientific investigations. 1. Lunar soil studies. The lander will analyze lunar regolith to understand its properties and composition. 2. Magnetic field measurements. The mission will study the Moon's magnetic fields to gain insights into its geological history and structure. 3. Technology validation. Blue Ghost will test technologies for regolith sample collection and Global Navigation Satellite System (GNSS) capabilities. 4. Dust dynamics. Experiments will focus on lunar dust behavior, particularly how it interacts with solar wind and its implications for future missions. The payloads for this mission include Lunar Planet Vac LPV by Honeybee Robotics, designed for regolith sample collection. Radiation-tolerant computer RAD-PC by Montana State University, to study computing capabilities in harsh environments. Lunar Magnetotelluric Sounder LMS by the Southwest Research Institute, for magnetic field investigations. Electrodynamic Dust Shield EDS by NASA Kennedy Space Center, aimed at mitigating dust on sensitive instruments. In addition to scientific payloads, Blue Ghost will capture high-definition imagery of a total solar eclipse on March 14 and a lunar sunset on March 16, further enriching the scientific data collected during its mission. Technical specifications of Blue Ghost. The Blue Ghost lander is designed for stability and reliability. Standing 2 meters tall and 3.5 meters wide. It features shock-absorbing feet, engineered to minimize the impact during touchdown. Robust communication systems, including 1 X-band antenna and 3 S-band antennas for reliable data transmission. Solar panels, generating up to 400 watts of power to support operations during the mission. During descent, Blue Ghost will employ vision-based terrain relative navigation and hazard avoidance systems to ensure a safe landing, identifying potential landing hazards such as craters and rocks. Significance of the mission. If successful, Firefly Aerospace's Blue Ghost Mission 1 will mark the company as the second U.S. private entity to achieve a lunar landing, following in the footsteps of other private firms and government agencies. This mission not only aims to advance lunar research but also sets the stage for future exploratory missions aimed at establishing a human presence on the Moon. Public engagement and future prospects. The mission has garnered significant interest from the public and the scientific community alike. A live stream of the landing event is scheduled to commence at 1:20 a.m. Central Standard Time, showcasing the culmination of years of development and innovation. As part of its commitment to transparency and public engagement, Firefly Aerospace has invited individuals to follow along with mission updates and participate in live discussions surrounding the mission's significance and implications for future lunar exploration. Conclusion. Firefly Aerospace's Blue Ghost Mission 1 is a promising venture into lunar exploration underpinned by cutting-edge technology and robust scientific objectives. Scheduled for launch on January 15, 2025 and landing on March 2, 2025. This mission will play a crucial role in advancing our understanding of the Moon and the technologies needed for sustained human exploration. As we stand on the brink of a new era in space exploration, the Blue Ghost mission symbolizes humanity's enduring quest to explore beyond our planet and expand our horizons into the cosmos. The content about Firefly Aerospace's Blue Ghost Mission 1 presents several counterintuitive insights regarding the mission's context and implications in the realm of lunar exploration and commercial spaceflight. 1. Commercial spaceflight and national goals. The mission is primarily funded by NASA's Commercial Lunar Payload Services (CLPS) program, reflecting a growing trend where private companies are taking on roles traditionally held by national space agencies. This dynamic suggests that private entities can effectively contribute to scientific research and exploration, which might seem counterintuitive given the historic reliance on government resources for space exploration. The success of Firefly could shift perceptions about the capabilities of private companies in conducting significant scientific missions. 2. Cost-effectiveness and competition. The mission's budget of $101.5 million may appear substantial, but when compared to traditional government-led lunar missions, this cost is significantly lower. This raises questions about the efficiency of government-funded projects versus private endeavors. The implication here is that private companies can execute missions at a fraction of the cost, which could lead to increased competition and innovation in space exploration, potentially democratizing access to space research. 3. Scientific contributions beyond the Moon. While the mission aims to study the Moon's regolith and magnetic fields, it also seeks to validate technologies that may have applications on Earth, such as understanding cosmic weather influences. This dual focus may be counterintuitive, as one might expect lunar missions to be solely about lunar science. Instead, the mission illustrates a broader vision for space exploration where lunar studies can yield insights that benefit terrestrial science and technology. For the duration of operations, the mission includes approximately 14 days of surface operations, which corresponds to a full lunar day. The notion that a single mission can gather extensive data within such a limited timeframe challenges the perception that comprehensive lunar studies require prolonged missions. This efficiency could redefine future exploration strategies, suggesting that shorter missions can still yield valuable scientific results. 5. High-definition imaging of celestial events. The mission not only focuses on geological studies but also aims to capture high-definition imagery of a total solar eclipse and a lunar sunset. This aspect highlights a lesser-known facet of lunar missions: the potential for capturing unique astronomical phenomena. It suggests that lunar landers can serve dual purposes, acting as scientific instruments while also providing stunning visual documentation of events that may not be easily observable from Earth. 6. Technological validation in harsh environments. The mission involves testing advanced technologies like regolith sample collection and global navigation satellite system capabilities. The idea that these technologies can be validated in a harsh lunar environment may seem counterintuitive, as one might expect such validations to be confined to Earth. This aspect illustrates the potential for lunar missions to serve as testing grounds for technologies that can be used in more challenging environments, thereby accelerating the development of future space exploration tools. 7. Public engagement and scientific outreach. The emphasis on public engagement, as suggested by the planned livestream of the landing event, showcases a shift in how space missions are marketed and communicated. This is counterintuitive in an era where scientific endeavors are often perceived as distant and inaccessible. By involving the public through live events, space agencies and private companies can foster greater interest and support for lunar exploration. 8. Collaboration across institutions. The variety of institutions and companies involved in developing the mission's payloads underscores a collaborative approach to lunar exploration. This might counter the notion that space missions are primarily the domain of large space agencies. Instead, it reflects a community of diverse contributors working together towards common scientific goals, which could lead to more innovative solutions and discoveries. 9. Geological significance of the landing site. The choice of Mare Crisium, an ancient asteroid impact site for landing, may seem straightforward. But it carries complex implications for lunar geology and the history of the Moon. The understanding that this site is a former volcanic area suggests that lunar exploration can unveil significant geological processes that are not only relevant to the Moon but also to understanding planetary formation in general. This interconnectedness might challenge the perception of lunar missions as isolated scientific endeavors. 10. Sustainability of lunar presence. The mission is framed as a stepping stone towards a sustainable human presence on the Moon, which may seem overly ambitious given current technological and logistical challenges. However, the mission's design reflects a pragmatic approach to achieving long-term goals in space exploration, emphasizing that incremental advancements in technology and scientific understanding can lay the groundwork for future endeavors. In summary, Firefly Aerospace's Blue Ghost Mission 1 encapsulates a range of counterintuitive insights about the evolving landscape of lunar exploration and commercial spaceflight. The mission not only aims for scientific advancement but also seeks to reshape perceptions about the role of private companies in space, the efficiency of lunar missions, and the collaborative nature of modern scientific inquiry. Significant aspects of Firefly Aerospace's Blue Ghost Mission 1 that are often overlooked. 1. Commercial spaceflight milestone. While many reports highlight that Blue Ghost Mission 1 is significant for NASA's Artemis program, they often overlook the broader implications of this mission for commercial spaceflight. If successful, Firefly Aerospace will become the second U.S. private entity to accomplish a lunar landing. This achievement will be a critical milestone, showcasing that private companies can successfully contribute to space exploration alongside national agencies, thus paving the way for future commercial lunar missions. The significance lies not only in the technological achievement but also in the potential for a more robust commercial space economy, encouraging innovation and investment in aerospace technologies. 2. Technological validation. The mission is set to validate various emerging technologies that could be crucial for future lunar and even Mars exploration. For instance, the Lunar Planet Vac LPV and Electrodynamic Dust Shield EDS are pivotal not just for lunar exploration but also for addressing challenges related to dust in space environments that can affect equipment and human health. The successful demonstration of these technologies could lead to advancements in planetary protection and habitat construction, which are vital for long-duration missions. 3. Focus on lunar regolith. The scientific investigations focusing on lunar regolith and magnetic fields are often underrepresented in summaries. Understanding the composition and behavior of lunar soil is essential for several reasons. It informs future resource utilization strategies such as in situ resource utilization for fuel and life support, helps scientists understand the Moon's geological history, and provides insights into the solar wind's interaction with the Moon's surface. This knowledge is crucial for establishing a sustainable human presence on the Moon and can directly impact future missions to Mars and beyond. For interdisciplinary collaboration, the mission's payloads are sourced from a diverse array of institutions and companies, including NASA, universities, and private sector entities. This collaboration signifies a trend towards shared expertise and resources in space exploration, illustrating a model of cooperation that could enhance the efficiency and effectiveness of future missions. The interplay between academia, industry, and government can lead to innovative solutions and accelerate the development of space technologies. 5. Environmental monitoring. The mission will capture high-definition imagery of astronomical events such as a total solar eclipse and a lunar sunset, which are often seen just as opportunities for stunning visuals. However, these observations are significant for scientific reasons. They can provide data on how lunar dust interacts with solar radiation and how these interactions affect the lunar environment. Understanding these phenomena can inform future lunar-based designs and operational strategies by shedding light on lunar weather patterns and environmental conditions. 6. Historical context of Mare Crisium. The choice of Mare Crisium as the landing site is strategically significant. This region is not just another landing site, it has historical geological importance. Being an ancient impact basin that has undergone volcanic activity. Studies in this area could yield insights into the Moon's evolutionary history, helping scientists piece together the timeline of lunar geological events. By focusing on a site with such rich geological history, the mission aims to contribute to a deeper understanding of planetary formation and evolution, which has implications beyond our Moon. 7. Impact on Earth sciences. While the primary focus is lunar exploration, the mission's findings will likely have implications for Earth sciences as well. For example, insights gained from lunar dust dynamics can inform how cosmic weather affects Earth, which is increasingly relevant in the context of space weather forecasting. Understanding these interactions can enhance our preparedness for solar storms and their potential impacts on satellite communications and power grids on Earth. 8. Mission duration and operations. The mission's timeline. Spanning approximately 60 days with 14 days of active surface operations is often simplified in reports. The operational phase's length is crucial for understanding the mission's logistics and planning for future missions. It reflects the complexity of sustaining operations in a lunar environment where day-night cycles last for 14 Earth days. This aspect of the mission emphasizes the need for robust systems capable of functioning under extreme conditions and informs future mission planning for long-term lunar habitation. 9. Future exploration pathways. The successful execution of Blue Ghost Mission 1 could influence NASA's Artemis program and broader lunar exploration initiatives. Successful landings by commercial partners could encourage NASA to rely more on private companies for future missions, thereby fostering a collaborative ecosystem. This could lead to a more sustainable model for lunar exploration where commercial entities play a key role in logistics operations and possibly even colonization efforts. 10. Cultural and educational impact. The mission's potential to capture unique astronomical events and its collaboration with various institutions may also inspire future generations in the fields of science, technology, engineering, and mathematics STEM. By engaging the public with live updates and educational outreach, Firefly Aerospace can stimulate interest in space exploration and innovation, which is often underplayed in many reports. This cultural impact can help foster a new generation of scientists and engineers who will drive future advancements in space exploration and technology. Conclusion. Firefly Aerospace's Blue Ghost Mission 1 is not just a pivotal step in commercial lunar exploration, it is a multifaceted mission with implications that reach far beyond its immediate objectives. The technological validations, scientific investigations, and collaborative efforts involved suggest a significant shift in how we approach space exploration, emphasizing the importance of interdisciplinary partnerships and the potential for commercial contributions to future missions. By recognizing these often overlooked aspects, stakeholders can better appreciate the mission's broader significance and its potential to shape humanity's future in space. 1. Mission significance and context. Firefly Aerospace's Blue Ghost Mission 1 represents a significant milestone in commercial space exploration, particularly as it aligns with NASA's Artemis program. With a budget of $101.5 million sourced from NASA's Commercial Lunar Payload Services (CLPS) program, this mission not only aims to achieve a successful lunar landing but also serves broader scientific and exploratory goals. The mission is poised to deliver 10 scientific payloads to Mare Crisium, contributing valuable data that will support future human lunar activities. This endeavor highlights the growing partnership between government space agencies and private companies, marking a shift toward a more collaborative approach in space exploration. 2. Technological innovations in payloads. The Blue Ghost lander is equipped with advanced technologies that enhance its operational capabilities. It employs a combination of vision-based terrain relative navigation and hazard avoidance systems to ensure a safe landing, demonstrating the application of cutting-edge navigation technology in space missions. The payloads, including instruments like the Lunar Planet Vac by Honeybee Robotics and the Radiation-Tolerant Computer by Montana State University, are designed to conduct unique scientific experiments. These payloads will explore lunar soil composition, assess magnetic fields, and investigate lunar dust dynamics, providing insights not only beneficial for lunar exploration but also for understanding cosmic influences on Earth. 3. Timeline and operational overview. The mission's timeline is meticulously planned, with the launch scheduled for January 15, 2025 and the targeted lunar landing on March 2, 2025. The mission will last approximately 60 days, with about 14 days allocated for surface operations. During this period, the lander will perform various scientific investigations, including capturing high-definition images of a total solar eclipse and a lunar sunset. These operations will not only contribute to lunar science but also provide data on how solar influences affect lunar environmental conditions. This clear timeline underscores the mission's structured approach to both scientific inquiry and operational execution. 4. Implications for future lunar exploration. If successful, Blue Ghost Mission 1 will position Firefly Aerospace as the second U.S. private company to land on the Moon following SpaceX's achievements. This accomplishment is pivotal as it paves the way for future lunar exploration missions, supporting NASA's vision of sustainable lunar presence as part of the Artemis program. The data collected during this mission will inform subsequent missions, potentially leading to advancements in lunar habitation, resource utilization, and broader exploration initiatives. Furthermore, it solidifies the role of private companies in the space sector, indicating a shift towards a more commercially driven approach to space exploration and research. Conclusion. In summary, Firefly Aerospace's Blue Ghost Mission 1 embodies a critical intersection of technology, scientific exploration, and commercial partnership in the realm of space exploration. Its success could not only enhance our understanding of the Moon but also catalyze further advancements in lunar and space exploration initiatives, contributing to humanity's long-term aspirations for a sustainable presence beyond Earth. Here are 3 famous historical cases of lunar missions that bear similarities to Firefly Aerospace's Blue Ghost Mission 1. 1. Apollo 11, 1969. Apollo 11 was the first successful crewed mission to land on the Moon, occurring on July 20, 1969. Astronauts Neil Armstrong and Buzz Aldrin landed the lunar module named Eagle in the Sea of Tranquility, while Michael Collins remained in lunar orbit aboard the command module. Columbia. This mission was a monumental achievement in human space exploration, marking the first time humans set foot on another celestial body. The mission involved extensive scientific experiments, including lunar soil and rock sampling, which contributed significantly to our understanding of the Moon. Apollo 11, like the Blue Ghost mission, was part of a larger program, Apollo, which aimed to establish a human presence on the Moon and advance scientific knowledge. 2. Lunar Reconnaissance Orbiter LRO 2009. Launched on June 18, 2009, the Lunar Reconnaissance Orbiter is a robotic spacecraft designed to map the Moon's surface in unprecedented detail. The LRO's mission includes surveying potential landing sites for future lunar missions, assessing resources, and studying the Moon's geology and environment. The LRO has provided critical data that supports ongoing lunar exploration efforts, including NASA's Artemis program. Similar to how Firefly's Blue Ghost mission aims to gather data and validate technologies for future lunar missions, both missions emphasize the importance of scientific payloads and research in paving the way for sustainable lunar exploration. 3. India's Chandrayaan-2 2019. Launched on July 22, 2019, Chandrayaan-2 is India's second lunar exploration mission developed by the Indian Space Research Organisation ISRO. The mission included an orbiter, a lander Vikram, and a rover Pragyan. The primary goal was to explore the Moon's south pole region and conduct scientific experiments including the study of lunar soil and mapping the surface. Although the Vikram lander ultimately did not achieve a soft landing, the mission is notable for its ambitious goals and the scientific data provided by the orbiter, which continues to operate successfully. Similarly, the Blue Ghost mission is designed to deliver scientific payloads to the lunar surface, contributing to the broader goals of lunar exploration and fostering international collaboration in space science. Firefly Aerospace's Blue Ghost Mission 1, scheduled for lunar landing on March 2, 2025, represents a significant milestone in commercial space exploration and lunar research. This mission is part of NASA's Commercial Lunar Payload Services (CLPS) program, aiming to support the Artemis program, which seeks to establish a sustainable human presence on the Moon. Future outlook and predictions. 1. Commercial lunar exploration expansion. Firefly Aerospace's successful landing will likely catalyze a wave of commercial lunar missions. Other private companies may follow suit, investing in lunar landers and payload delivery systems. This could lead to a competitive landscape where multiple companies vie for contracts under NASA's CLPS and similar initiatives, driving innovation and reducing costs. 2. Technological advancements. The technologies tested during the Blue Ghost mission, such as regolith sample collection and lunar navigation systems, will pave the way for advancements in space robotics and autonomous systems. Success in these areas could enhance future lunar missions, including crewed expeditions, by providing more reliable and efficient tools for exploration. 3. Increased scientific research. The mission's payloads, designed to study lunar soil and magnetic fields, will contribute to a growing body of scientific knowledge about the Moon. This research could lead to new discoveries regarding lunar geology, the Moon's formation, and its potential resources such as water ice. Future missions might build on this foundational knowledge, exploring more complex scientific questions and experiments. 4. Collaboration between public and private sectors. The Blue Ghost mission exemplifies the growing collaboration between NASA and private aerospace companies. As more missions are conducted, this partnership is expected to strengthen, leading to joint ventures in technology development, resource sharing, and even crewed missions. This synergy could streamline operations, reduce costs, and accelerate timelines for lunar exploration. 5. Broader implications for space exploration. The success of the Blue Ghost mission could set a precedent for future missions beyond the Moon, including Mars and asteroids. Lessons learned from lunar exploration will inform strategies for deeper space missions, particularly in terms of landing technologies, resource utilization, and long-duration habitation. 6. Public engagement and interest. As commercial lunar exploration gains traction, public interest in space will likely increase. Successful missions like Blue Ghost can inspire educational initiatives, STEM programs, and public engagement through live broadcasts and interactive content. This could foster a new generation of scientists and engineers excited about space exploration. 7. Sustainability in space exploration. The emphasis on sustainability within the Artemis program and commercial missions will likely lead to innovative practices in space. This includes developing technologies for in-situ resource utilization (ISRU), which can reduce the need to send materials from Earth. Future missions may focus on harnessing lunar resources to support long-term habitation and exploration. 8. Lunar infrastructure development. If Blue Ghost Mission 1 is successful, it could act as a precursor to establishing lunar infrastructure. This includes potential bases for scientific research, mining operations, or staging areas for deeper space missions. Continued exploration may lead to plans for permanent human settlements on the Moon. 9. International collaboration. As lunar exploration expands, international collaboration may become more prominent. Countries with space programs may join forces for shared missions, pooling resources and expertise. This could enhance global partnerships and establish norms for space exploration. 10. Regulatory and policy evolution. The increasing number of commercial missions will necessitate the evolution of regulatory frameworks governing space activities. Governments may need to establish guidelines for resource extraction, environmental protection, and liability in space. Shaping the future legal landscape of lunar and extraterrestrial exploration. Conclusion. Firefly Aerospace's Blue Ghost Mission 1 is poised to be a significant leap forward in lunar exploration with implications that extend far beyond the Moon. If successful, it will not only solidify Firefly's position as a major player in the aerospace industry but also inspire a new era of exploration, collaboration, and technological advancement. The mission underscores the potential of private companies to contribute to humanity's exploration of space, setting the stage for exciting developments in the coming years.